a journey of the universe, how it was created, how it is today, and what will it become in near future. So sit back and let us begin the journey of our existence. We will be discussing all events in a nutshell, and we'll have a brief discussion on each event. So let us begin.
Event: the birth of the universe. About approximately 13.7 billion years ago, a very well-explained phenomenon took place: the Big Bang. Traditional Big Bang theory posits that our universe began with a singularity, a point of infinite density and temperature whose nature is difficult for our minds to grasp.
So the question arises, why this Big Bang theory is accepted around the world? Well, scientists believe that this event created a massive explosion that blew space up like a gigantic balloon. And from that point of time, it took around more than 7 days to create the universe we know today.
We know that the universe is still expanding, and now even at an ever-accelerating rate. During inflation, dark energy made the universe smooth out and accelerate. But it didn't stick around for long. However, scientists don't know what might have spurred inflation. That remains one of the key questions in Big Bang cosmology.
This is the stage of baby universe, which lasts only around the first picosecond of cosmic time. The four fundamental forces of universe were yet to born. First, the gravitation, then electromagnetic, and later weak and strong interactions. These were known to be formed during the expansion and cooling of the universe.
Tiny ripples in the universe at this stage are believed to be the basis of large-scale structures that form much later. Different stages of a very early universe are understood to different extents. The earlier parts are beyond the grasp of practical experiments in particle physics, but can be explored through other means. Event: the early universe. Lasting around 370,000 years.
Various subatomic particles were initially formed in this stage of universe. These particles include almost equal amounts of matter and antimatter, so most of it quickly annihilates, leaving a small excess of matter in the universe.
At about 1 second, neutrinos decouple. These neutrinos form the cosmic neutrino background. Scientists believe that if primordial black holes exist, they are also formed at about 1 second of cosmic time.
A cosmic time of 2 minutes is suitable condition for nucleosynthesis. But by the time of 20 minutes, universe not remains enough hot for nuclear fusion, but it remains sufficient hot for the existence of neutral atom and for the photons to travel far. The recombination epoch begins at around 18,000 years, as electrons are combining with helium nuclei to form helium plus ions. at around 47,000 years. As the universe cools, its behavior begins to be dominated by matter rather than radiation.
At around 100,000 years after the neutral helium atoms form, helium hydride is the first molecule. Much later, hydrogen and helium hydride react to form molecular hydrogen, the fuel needed for the first stars. At about 370,000 years, neutral hydrogen atoms finish recombination, and as a result, it also became transparent for the first time.
The newly formed atoms, mainly hydrogen and helium with traces of lithium, quickly reach their lowest energy state, ground state, by releasing photons, photon decoupling, and these photons can still be detected today as the cosmic microwave background, CMB. So, this is currently the oldest observation we have of the universe.
Event: the Dark Ages and large-scale structure emergence.
After recombination and decoupling, the universe was transparent, but the clouds of hydrogen only collapsed very slowly to form stars and galaxies, so there were no new sources of light. The only photons in the universe were those released during decoupling, visible today as the cosmic microwave background, and 21 centimeters radio emissions occasionally emitted by hydrogen atoms.
The decoupled photons would have filled the universe with a brilliant pale orange glow at first, gradually redshifting to non-visible wavelengths after about 3 million years, leaving it without visible light. The period from 370,000 years until 1 billion years is known as the Cosmic Dark Ages.
Between about 10 and 17 million years, the universe's average temperature was suitable for liquid water, and there has been speculation whether rocky planets or, indeed, life could have arisen briefly, since statistically a tiny part of the universe could have had different conditions from the rest as a result of a very unlikely statistical fluctuation and gained warmth from the universe as a whole.
At some point, around 200 to 500 million years, the earliest generations of stars and galaxies form, and early large structures gradually emerge, drawn to the foam-like dark matter filaments, which have already begun to draw together throughout the universe.
The earliest generations of stars have not yet been observed astronomically, but they have very short lifetimes compared to the stars we see today, so they burn their fuel and explode as highly energetic pair instability supernova. Very short lifetimes compared to the stars we see today, so they burn their fuel and explode as highly energetic pair instability supernova after mere millions of years. Scientists believe that these early generations of supernova created most of the everyday elements we see around us today and seeded the universe with them.
Galaxy clusters and superclusters emerge over time. At some point, high-energy photons from the earliest stars, dwarf galaxies, and perhaps quasars leads to a period of reionization that commences gradually between about 250 to 500 million years and is complete by about 700 to 900 million years and diminishes by about 1 billion years.
So, the universe gradually transitioned into the universe we see around us today, and the Dark Ages only fully came to an end at about 1 billion years.
Event: the universe as it appears today.
From 1 billion years, and for about 12.8 billion years, the universe has looked much as it does today. Scientists say that the universe will continue to appear very similar for many billions of years into the future. The thin disk of our galaxy began to form at about 5 billion years, and the solar system formed at about 9.2 billion years. With the earliest traces of life on Earth emerging by about 10.3 billion years since Big Bang.
From about 9 billion years of cosmic time, the slowing expansion of space gradually begins to accelerate under the influence of dark energy, which may be a scalar field throughout our universe.
The present-day universe is understood quite well, but beyond about 100 billion years of cosmic time, about 86 billion years in the future, uncertainties in current knowledge mean that we are less sure which path our universe will take.
Event: the far future, an ultimate fate.
At some time, we don't know when, the Stelliferous era will end, as stars are no longer being born, and the expansion of the universe will mean that the observable universe becomes limited to only local galaxies. There are various scenarios for the far future and ultimate fate of the universe. More exact knowledge of our current universe will allow these to be better understood.
Following events are the assumptions made according to certain theories. Have a look to understand each event.